Okay. Hello, everyone. So, the roots of this talk are from my visit to India maybe like 2 years ago. So, I visited one of my old uncles here in India, and he's like all into astrology and stuff. So, I saw him but he's like all modern. So, he has this nice Samsung phone. He pulls that out and then like makes some charts and helps people with that. But I saw that the app was like really bad. It didn't work well, and so that's when I decided that I should use my programming superpowers and help him like and make like a really great app for him. But so when I started looking online, I realized that I had to like do everything from scratch, like create a REST API backend server. And there's a really cool library for the calculations and stuff. So that is all in C. And I wanted to make use of that, but I did not want to write everything in C or C++, although I do that for a living. But so I definitely wanted to use Go, as it's so much easier to do things in Go. But I also didn't want to run both the things in their own processes and then do IPC, because that is a lot of work, more testing, and like error handling, all of that. So I'd used JNI in the past, so I knew there must be definitely something for like using Go and C together, run them in the same process. So that's when I came across CGO. And so, and after 2 years after that, I'm here to like give a talk on it. Just some basics and also like some of the tricks that I learned and were helpful to me, and also maybe some of the issues that you should consider when you have to use CGO. So what is CGO exactly? So I think CGO is like this Superman. It is extremely strong and powerful because you can have both C and Go running at the same time, but but you can call functions from C to Go and the other way. So it's like this Superman which is holding the two sides together. So when do you want to use CGO? So like me, if there's some popular C or C++ library, then to use that with Go, you'll want to use CGO, or one of the things that is like that the Go mobile project does is, so it uses C as like the intermediate language. So you basically write Go code, then that's like that calls something in C, and then that C code calls back to the platform language, so like Java or Objective-C. So that's like really cool. The project is still experimental, but I really like that. Also, C is like the most portable language. It works almost everywhere. So you can even like call Lisp from Go if you know CGO and something between C and Lisp, because I think like all languages have some way to execute like C functions. So CGO is definitely like useful, and even if you want to do like call system functions, then those will have to be in C, and you'll have to use CGO to call them from your Go application. So when we're learning any new language or anything new with a language, we usually start with a hello world program. So here in this case, there could be like two hello worlds, or so I'm calling them like hello CGO and hello Go C. So I'll just explain as we go ahead. So for hello Go C, the main application entry point is in Go, and we are calling a function from C. So this both these examples are really simple, but you can build upon them to make like complicated apps. So let's look at some code. I hope this is visible. So this is really a simple code where we print hello world to the console, And so the way this works is, so we have the usual package main statement at the top of the file. Then there's a block of comment, followed by import C. So this block of comment is very interesting. This is not like any other comment where the comment is just thrown away when the application is built. This is actually executable code. And the way the build tool knows that this is an executable block of code is because of the import C statement. And so this import C statement should be right after this code block. You cannot have an empty line or anything in between. Also, the import C statement cannot be combined with the other imports. And that is because the C package is not a real package. And there is no, so if you look up, you won't find like source for the C package or anything. It's like a pseudo package. And I'll tell you later why it is a pseudo package and also briefly how it works. But for now, so we see that the main function calls the getString function, and the getString function is the C code in the command block. So yeah, in the main Go function, we first get the string and store it in a Go variable. And when we want to print it, we convert that to a Go string. So we do that using the Go string function. So the Go string function is a built-in function. It will just take the string from C, copy that, and then convert that to a Go string. So, and yeah, to build the code, you just use the usual go build command, and it'll figure out that it has to call the CGO tool to call the C compiler to build the C code. Now, let's look at the other part, or the other way, where C is the application entry point. I think most of you must have seen seen the Go C way, where you always start in Go and then call something from C. But this one's interesting because and this also wasn't supported it's been supported like recently in the recent versions of Go. Because earlier you couldn't build a static or you couldn't build libraries from Go code. So these are the two files that are built separately and then linked together to create an application. And the entry point for the application is written in C. So first we write the code in the Go file, and that's on the right side. So we again have the import C statement there and just a regular Go function which returns the string. And at the top of the Go function, we have a comment which says export and then something after that. This export is extremely important. This is because once we build this code into a library, we want this function to be exported from the library so the C code can call it. The build command is written at the bottom of this file. And so it's basically the go build command with the build mode flag passed to it. And the values for build mode can be like C archive, C shared, or there are even other different values. But I'm just doing C archive here because I'm building a static library. Now we have the static library built. So then we just write C code and link this static library to it. So on the C side, we have the main function where we call the getString function. That is on the Go side, and it's exported from the library, so that'll all work. But the important thing here is the free. It's extremely important to not forget freeing the memory, and that's because we are allocating memory using C string. So in the Go file, we call c.cstring, which will do malloc on the C, on the C heap. And so memory is allocated on the C heap, and Go cannot control this block of memory. So it has to be freed like you do for any other C, like malloc and free. And then we just build this code uh, like like you would do for any C application. You have the C file and then pass the static library to it. So the building code is pretty easy. It's just like more work for the Go build tool to do, but nothing much more for us. So what this means is that when you write Go build and then the Go file name, the Go build tool knows that it has to call the CGO tool for building the code, and so it will invoke Go tool CGO with some parameters, and then we'll get like an intermediate set of files, and these files are then linked together to create the final binary. If you want to build C code separately and then link it, then you can do all that with a makefile. You can also have like all your C code in one directory, then write Go code also in the same directory, and then the Go build tool will figure out and it will build everything in the current directory. For CGO to be enabled, you have to have the CGO enabled flag set. By default, it is always set, so you mostly wouldn't have to worry about it. And you can also specify flags for the C or C++ compiler and the loader flags. So all these are for building the C code, and you can specify those when, like you can export those and use those for building with the Go build tool. So this code is, these are just parts from the intermediate code that is generated from the Go code. So on the top, you see the main function that we saw earlier. So this is pretty similar to this one. So this main function calls c.getString, and then we do c.goString. And then when you build that, it generates this intermediate code. And so here we see that the c dot is basically converted to something else. And that's what I meant when I said that it's a pseudo package. That's because it's not a real package, and then these functions have some other like definitions. You'll find all of those in the intermediate build code. And so the second half, or more than half, but so in the second part, you'll see the definitions for those functions. I've just put like some small parts here. But the important thing here is these are functions that are created by the build tool, and then these call the CGO runtime, and then the CGO runtime will handle switching stacks and all of that stuff. And yes, to get these files, you can just run the Go tool, CGO, and then the file name. So how would you convert types from like C to Go? Or basically, how do you declare variables with C types in Go when you want to use CGO? So these are just type mappings. So it's pretty simple. You have int in C, you do c.int. And so similar for the others. And for structs, unions, and enums, you just prefix those on the Go side with like struct union and enum, and then the actual name of those. And void stars become unsafe pointers on the Go side. So we saw the cstring function earlier, or cstring and even the goString function. So those are all given like on the Go documentation website, and so the important ones from those are the C bytes and Go bytes. The cstring functions are essentially the same as C bytes and Go bytes, so I don't have them up here. But C bytes, it'll take a Go byte slice and convert that to a C array. And by convert, I mean it'll malloc memory. It'll copy the data into the allocated memory. And so which also means that once you're done using this, you have to free the memory. And similarly for Go bytes, it will take data from the C memory, copy that to Go, and that's it. You don't have to worry about like freeing memory here. So yeah, we saw a simple example of calling C functions from Go, but the example here shows that a like some function returns two values. So that's not actually what happens, but the ERR is something that Go pulls from the error number variable in C. So whenever we are writing any C code, we can set the error and then just return from the function. And then on the Go side, we can get the value from that error and then proceed like whatever, like what we want to do after that. And similarly for Go functions can themselves return multiple values. And to get those on the C side, you'll have to pull them out of a struct that is created. So Go can return like any number of values, and then when you call that function from C, you'll get a struct, and you pull out the respective values from that struct. Function pointers. So yeah, this is interesting. So you can actually store function pointers, but calling function pointers from Go is not supported. So function pointers are a C way of like having pointers to functions, and it's very complicated. I don't like the syntax of that, but they're still there in many places. Like even the, yeah, I saw like one example from a SQLite, and so they also use like the Go wrapper for SQLite uses function pointers and also the wrapper functions, which is one of the solutions to using function pointer, like or calling function pointers in C from Go. So let's look at another example. So not all of this is important, but so on the left side we have the C file, and so on the comment at the top we see the type def. So that's actually defined in the header file. There was no place to put the header file, but so I have it here. So this is actually the type def for the function pointer. And when the get magic func returns this function pointer. So from Go, what we can do is in the main we call c.getMagicFunc. This will return a function pointer, and fptr has this function pointer. So now, yeah, we cannot just do c.fptr, as that doesn't make sense. fptr is a Go variable, so that's the reason we cannot directly call function pointers. And so that's why what we have to do is create something like a wrapper function, which is basically like it's shown in the C code and the get magic number. So the first parameter is just the function pointer, and then you just send all the arguments that the specific function will take. And that way you can use the function pointer variables from Go and call the respective C function. So yeah, we all know Go is garbage collected and C is not. But because of that, there are, like, you always have to remember that you manage memory properly, which means like freeing memory like we saw before. And there are also a bunch of like complicated rules written out on the Go side, where it says if you have a struct in Go, then that struct cannot have another struct which has Go pointers, and it's very complicated. So I'm not going to go deeper into that. So you won't always come across that. It's not very common, but if you do, you can look up the documentation at that time. But one of the things and ideas that I like and I've used a lot is using the runtime.setFinalizer. So that is to wrap C objects in Go objects, so that when the Go garbage collector is called, it will in turn free the C memory as well. So here's a short example for that. So the C function, the main C functions are like create time, get time, and free time. So create time, as it says, it will allocate memory, and free time will free memory. Get time will just take a time pointer and then return a string for that. So how we wrap that on the Go side is by just creating a struct with that data type. And so that's the c.time_t, that's a data type. So we create a Go struct with that. And then, according to Go conventions, we create like a new nice time function. So in this function, we create the object, and then we also set the finalizer for that object, which means that whenever the Go garbage collector tries to free the object for nice time, it will also call the free function, and the free function will in turn call the C free time function. So we don't leak memory, and we are good to go. And yes, again, the build is same. So yeah, we always use Go channels, and that's what Go is for, and that's how I also started using Go. But when we are calling CGO or C functions from Go channels, we have to remember that anything or any call to C from Go is a system call, which means that that Go routine and that thread will be taken by the Go scheduler until the function returns. So all the resources or that thread will be taken, and if you have like thousands of Go routines and all of them call C functions, then you can essentially like block or stall the application, and that depends on the Go max procs. However, if you have the C program and that internally uses its own threads, then those are not counted against Go max procs. So now we have done all these things, we have written the program, but we have to still think about the performance. So we saw like memory leaks, all of that, and how to take care of those. But performance is not free. So when you're going across languages and crossing language boundaries, you have to know that the Go runtime will switch stacks, and that is an expensive operation. So for the simple hello program, I saw that the Go version took like 1 nanosecond, and the CGO version took like 100. So yeah, so this means it's pretty expensive. It's 100 times slower, but also 100 nanoseconds is still okay. But if you start doing this in a tight loop, it's really bad in that case. So what you can do then is put all the data in an array and then send that array over, so that you just cross the boundary once and another time to like get the response data. You also need to think about memory copying, and sometimes the solution could be moving more logic to the C layer so that you avoid copying memory frequently. And also, this will hamper build and developer performance, because every time you build code, you call the C compiler, and although the Go compiler itself is really fast, C compilers may not be fast. They try to optimize and do a lot of things. So that's another important thing. Finally, I would say that you should never start creating a new application with the intention of using CGO, like with the intention of writing some shared C code and then calling that from Go. You have to use CGO only if you really need to, for the things that I explained before. like system calls and things like that. But once, like, if you have to use it and you're using it, you have to remember that you are crossing the language boundary, and both the languages are different. So you have to remember how they work and make sure that you don't, like, you avoid memory leaks and think about performance and things like that. That's it. Thank you.
Questions? This is that time of the day when everyone wants tea and coffee, I think, right? Okay. Thank you, Nitish. Thank you so much, guys.